So my research is about symmetric key cryptography. And traditionally, what that would mean is that you have two parties with a shared key, and they want to communicate in a confidential way. But nowadays, that's actually a much broader and more fundamental research field. So now we also look at things like authentication, cryptographic hashing, and even very basic things like being able to generate unpredictable bits. So my thesis is about symmetric key cryptanalysis, which means the security analysis of symmetric key cryptography. And what I've looked at more specifically is the cryptanalysis of primitives. And these are really the basic building blocks from which we create all of symmetric key cryptography. So I'm talking about things like block ciphers and cryptographic permutations. So I think that symmetric key cryptography is one of the most widely used forms of cryptography. And that's because anytime you have any sort of cryptography that's being deployed, it will usually rely on symmetric key cryptography as a basic component. And so this goes from things like cryptographic protocols like TLS, which you use for secure browsing, where you would need authenticated encryption. Or it can be for signature schemes, where you need collision-resistant hashing. And it even goes to very basic things that we sometimes forget about, such as being able to generate our keys or generate randomness that we need in other protocols. So for me, the most exciting thing about symmetric key cryptanalysis is that it's possible to build a general theory about it. And so you can do it in a very systematic way. So in particular, even though we have quite different types of ways of building these primitives, there are actually some techniques like linear, differential, and integral cryptanalysis that are universal. And what's even more interesting is that they fit surprisingly well into a general theory. And so that was something very exciting for me to see. And it's also nice to be able to work with other people here, for example, mathematicians and so on, that are also interested in that. My plan for the future is to continue working in symmetric key cryptanalysis. And that's because I think it's a really exciting field right now. On the one hand, you have many practical applications because it's really important to know that the cryptography that we use is actually secure. And the honest answer is that right now we don't actually know if that's the case. So I hope to do this from the academic side. And the reason for that is that I think right now there are a lot of possibilities on the theoretical and more academic work. So like I said, there's this general theory that we can build. And I think in the past, because many of the problems in our field are open, in the past it has been difficult to enter the field because you have to know sort of where to start. And now, because of this, it's possible to make connections, for example, with areas of mathematics. And that gives us sort of a good direction to start looking in.